Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be looking at iteration, but specifically when we are given a context. So definitely make sure that you've watched the first video in the series on iteration just generally, so you've got a concept of how that works and how the process works. We won't necessarily be explaining it that much here, we'll just be going straight into more so how the context works, or how the questions look when they're given a context. So you can see here, we've not really got X values or anything like that. We have still got some numbers and a formula, but we've been given an actual real life context. So the number of people living in a city at the start of year N is basically represented by the letter P, so P for population, N, so for that year. The number of people living in the city at the start of 2025, so they've now given us an actual value, is 360,000. So this would be our, if you've seen that other video, effectively our x0, isn't it? Or in this case, p0. That's our starting point. That's what they're telling us. Start here. Then if they're given that, p, n plus 1, is equal to 1.30 multiplied by pn, work out the number of people living in the city at the start of 2028. So hopefully you can look at this and you can see, even though they haven't mentioned the words iteration in the question, but it's the same concept, isn't it? We've been given a formula where we have to take the previous answer, so in this case the previous population, substitute it into this formula to then find the population for the following year. So here we want to work out 2028, so how do I get to 2028? Think about iteration, especially that we mentioned it's normally 3 times, isn't it? I'd probably lay it out like this. P 2025 was that, wasn't it? That was P 2025. P 2026, you can use P1, P2, P3 if you like. You can use X1, X2, X3, whatever makes sense to you. But I'm just going to write the actual year so that I don't lose track. So how do I go from 2025 to 2026? I just need to substitute in the previous year, so 2025's population, into the formula. And if you really want to look at this in detail, we're effectively saying there's a 3% increase every year, aren't we, basically? But sometimes the formulas are a little bit more complicated than just that. So if you have watched that first video, you'll know the trick on the calculator. So just type in the first answer, so that's the 360,000 in this case. Press equals so it saves as your answer. And on top of that, just write your formula. So 1.03 multiplied by the answer. So my population for 2026 is 370,800. And then for P 2027, I won't write down that I've substituted it in again. I will demonstrate it to them once that you know that you have to substitute in the previous value to get the next one, but you don't necessarily have to write it again. So all we want to do is bring back the calculator and press equals again. And now it gives me my next answer. So the next population for 2027 is now 381,924. And then we just want to do it once more because we're trying to get to 2028, aren't we? So press equals once more. Try not to lose track of how many times you pressed equals, otherwise you might have an incorrect answer. Now, if you do get one with decimals and they're obviously referring to a context of, in this case, people or animals or anything like that where it should be a whole number, I would probably just round it. So in this case, I'll round it up. So we've got 393,382. So in this case, because we're looking for 2028, that is just the final answer, isn't it? The 393,382 people. So it's exactly the same as the iterative process, they just haven't really mentioned it. Okay, similar question here, we've now got 2 parts though. So the number of butterflies in a butterfly garden in n days is Pn. We've been given the formula here, it's just been written differently, but it's the same type of question, isn't it? Pn plus 1 is equal to 1.4 multiplied by Pn. And then subtract 120. So we're taking our previous amount of butterflies, substituting it in, to then get the next number. In this case, it's now in terms of days for the next day, whereas the previous one was in terms of years. And they've given us a starting value, so P0 is 800. Part A, work out how many butterflies there will be after 4 days. Okay, so normally it's 3 times, but they might ask you for more. So P1 would be the 1.4, substitute in the previous amount, which is 800 minus 120, so our starting amount is 800. Just save that in the calculator. Then type in the formula. Okay, so for the first day, we've now got 1,000 butterflies. Then for the second day, we've got 1,280 butterflies. For the third day, press equals again, 1,672 butterflies. And then lastly, for the fourth day, we've then now got a decimal, so I'd probably just round that to 2,221 butterflies. So that's our answer, isn't it, for the fourth day? 2,221. Now, we have got part B, which is a worded question, so considering your answers in part A, suggest what will happen to the number of butterflies in the garden over time. So just look at the pattern. What has happened? We started with 800, then 1,000, 1,280, and so on. What is happening over time to the population? Just think of the most basic way to explain it. It's increasing, isn't it? So the number of butterflies, it will increase. Some version of that, you obviously don't have to write exactly word for word, but some kind of version of that, it will go up, the population is increasing, it will get bigger, that kind of thing, because that's the pattern, isn't it? You might get iteration where the values are actually decreasing, that's also possible. In which case you will say, oh, well the number of, let's say it's butterflies, the number of butterflies will decrease, or if it's over a long period of time, you'll get to a point where it will obviously decrease to the point where it's 0, isn't it? So you could say that. But just check, is the pattern increasing or is it decreasing? So really easy part B question there. Now my final question here is a slightly different context, so it's not really populations anymore. So we've got a plane starts its descent. The altitude of the plane, n minutes after it starts its descent, is an. The altitude of the plane, n plus 1 minutes after it starts its descent, is given by, and now we have our formula. So to find the altitude a minute later, we have to do k multiplied by the altitude currently plus 50. Where k is obviously a constant, so constant just means it's a number, right? The plane starts to descend from an altitude of 37,000 feet at 1805. At 1806, the altitude of the plane is 35,200 feet. Work out the altitude of the plane at 1808. So a slightly harder question here, although it's still iteration. Can you see how we've been given some kind of iterative formula? And now we're working in minutes instead of days or hours. Now, we don't actually have the whole formula though, because we don't know what k is. And obviously we need to know what k is in order to get an actual numerical answer. That's why we've been given this extra piece of information here. So first of all, before I can work out A1, A2, A3 and so on to get to 1808, I actually need to know what k is. So I'm going to just set up two equations. The starting value is 37,000 feet, isn't it? That's our starting value. And then to find the next minute later, so let's say here, A0, you can lay it out as you want, as I said before, you don't have to write it exactly like this. A0 is 37,000 feet. A1, so 1 minute later, which is the 1806, is equal to doing the previous amount, 37,000 feet, multiplied by k, so just stick a k there, plus 50. But I actually know what that equals to. That does actually equal to 35,200 feet. So do you see how here we've got this equation? Just think about just straightforward, simple algebraic equations, not even iteration at this point. Just equations. The only thing I don't know is k, and that's why I actually want to find out. So let's just rearrange this. So obviously I would minus 50 across. So 37,000k is 35,150, and then divide by 37,000. So you can see that the value of k is 0.95, which makes sense because we are descending. So the value in terms of feet, in terms of the altitude, should be decreasing. The multiplier is less than 1. So whereas in question 1 we saw it was 1.03, which is more than 1 as a multiplier, it's a population increase, we've now got something less than 1, so it's decreasing. So k is 0.95. So now I know my actual iterative formula is 0.95 multiplied by the previous altitude plus 50. Okay, let's go back to the question. We want to know the altitude of the plane at 1808. Now, we could start with 37,000 if you want, if that makes more sense to you, but obviously we've technically already found out that the next minute, A1, is 35,200. So I'm probably just going to go from there. So A2, which is kind of hard to keep track of, so if you want to write it, that's 1806, isn't it? That one's 1805. And this is then 1807, so we need to do two more. So A2 would be 0.95 multiplied by the previous answer, which was 35,200 plus 50. So my calculator, my answer is the 35,200 equals, and then type in the formula over that. So we're now at 33,490 feet. And we just need to do it once more to get to 1808. So just press equals once more. We've now got this. Again, you could leave it like that in this case because you can have half a foot, or you could round it. So 31,865.5 feet. So there's our final answer. So this one was just a little bit more complicated because we had to use the information we were given to set up an equation and find out the missing constant for the actual iterative formula. Once we had the formula, from there it was just the normal process, but obviously make sure you don't get confused with how many times you've already done it. We only needed to do it twice more technically, didn't we? So that should be everything you need to know about iteration. Obviously, if you haven't seen the previous 3 videos, go back and have a look at those as well. They will be linked down below, but otherwise, thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.